This is the ROS Developers Podcast, episode 49.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez from The Construct, and today I would like to dedicate the podcast to the ROS developers that participate at the European Robotics League. That is a robotics competition funded by the European Union where participants can compete in an urban environment. I know how difficult it is to make something work for real robots, so for all of those there that you are trying to do this to work and to make it work on the league, this episode is dedicated for you. And today is my pleasure to introduce you Francisco Martin. Actually, Francisco, that's the second time that he has been here at the podcast. And Francisco is an associate professor at the Rey Juan Carlos University in Madrid, Spain. And it's also a member of the Robotics Lab at that university. And actually, Francisco is a participant at the European Robotics League at one challenge, a specific challenge that is called the Smart CIties RObotics Challenge. For that competition, Francisco has created a ROS package named the Darknet ROS 3D. He's going to tell us today here about this package and how he and his team, they are using it at the competition. Welcome to the podcast, Francisco.
Thank you. Hi, Ricardo. How are you?
Fine, very fine. So before we started with the podcast, we have a very troublesome situation trying to record this.
Okay, we fix it.
Yes, we fix it. Well, actually, we are recording this and we are not 100% sure if it is being recorded.
Yeah. Okay. We have come to play.
Yeah. Exactly. So something similar happened 40-something episodes before when you went here at the podcast. So the thing is that we should have improved along all this time, but I don't know what happened. Maybe it's luck or bad luck that we have. I don't know.
Yeah.
Okay.
No problem.
Okay. So let's try to do our best, and let's hope at least somebody will listen to us someday. So first question that I want to ask you is about what is this competition that you are participating in, the one that called Smart CIties RObotics Challenges.
Yes, as you say, this is a European funded project supporting the European Robotics League. And the goal of this competition is bringing the European Robotics League to smart cities. So actually this competition will take part in Milton Keynes in a commercial center. So it's quite different from the situation in RoboCat at home, in which the environment was a home. Here is a commercial center.
But it's a real commercial center, you mean?
Yes, it's a real commercial center. There are several challenges. For example, one is deliver coffee shop orders, and another is take the elevator. Those are the two challenges we are going to participate. And it's a real restaurant and it's a real elevator. At least it's what we think is going to happen.
Okay, because it's the first time that this is done, this competition.
Yes, it's the first time.
Okay.
This the CIROC, it's like a event that will happen twice in 2019 and in 2021.
Okay.
So it's had two editions, as far as I know.
Okay, and one question which type of robot are you using there in order to participate? Is handmade or is a commercial robot?
No. We have never used a handmade robot. Once we participated with a robot made out of wood, but that was an exception.
Wood.
I have participated in RoboCat with Evo Robot, with Now Robot. Our last participation in RoboCat was the Pepper Robot, and this time we will use the Tiago robot from PAL Robotics.
The Tiago. Okay.
Yes, it's a very good robot, completely working in ROS. The people from PAL Robotics did a very good job in this robot.
Okay, and it's a standard platform, or anybody can use any robot?
Anybody can use any robot, but Tiago, the people of PAL Robotics did a call for loan, and if you want that call, you can access to a Tiago robot. Tiago is a very expensive robot, but with the call for loan, you have the Tiago with more accessible price.
Yes, it's like having robot as a service.
Yeah. And it has a very big advantage. We don't have to bring our robot to UK because PAL Robotics is going to have many robots there available to the teams. I think we will have to share it, but we'll have there a robot.
Okay, so then if I understood correctly, at present you don't have the robot.
Yes, I have. I have my robot.
You have your own Tiago, and then afterwards you are going to use another one there.
Yes.
Okay, I got it. Okay, and then you for that competition, you have built this package that is called the Darknet ROS 3D, which I will put a link below on the notes of this podcast, so for other people can check it. And what is this package about?
This package will use another packages like Darknet ROS. And this package will take the output of Darknet ROS. Darknet ROS will produce information about the image, the detection, the object detected in an image, but in 2 dimensions. Okay. It produces bounding box with bounding box in pixels coordinates with a class and a probability. So this package will take that output and will take the point cloud and will produce the same information, bounding boxes with the class, with the probability, but in 3 dimensions.
Okay, so you mean that it's just to clarify for the people who doesn't know about the subject. So there is a package that is called Darknet ROS. Yes. That's one package. And then there is the other package that you have built that is called Darknet ROS 3D.
3D.
Okay, so the second one is getting information from the first one. So
yes,
and also from a point cloud device.
Yes, and it follows the philosophy of ROS. It's similar to the philosophy of Unix. Do small things, small nodes that do things very good and connecting them in order to have a more powerful application. And in this case, we will take the pipeline that starts from the OpenNI driver. It follows to Darknet ROS, and we continue in another node that takes the information from this pipeline and from the point cloud, information from the RGBD camera, and it produces the information, but in 3D. That is very useful for us.
Okay, and when you mention information in 3D, what do you mean exactly? What is that kind of information?
It's not bounding boxes, it's voxels. Voxel in 3 dimensions with respect to any frame of the robot, with the class and the probability. If the Darknet ROS produces 2D information, we produce 3D information. The same, but in 3D.
Okay, so the Darknet is just like the camera is taking a picture, and then it says on this part of the picture of the camera there is a person or there is a book, and then your package, what it does is that it combines that with the point cloud device, and then it says so it's not only that there is a book here, but I can tell you that the distance from your camera or from your base link is this amount of meters, or on the right.
Yes, it produces the information in one frame of the robot.
In one frame of the robot.
Footprint or in map, if the robot is localized or whatever we want.
And what do you publish? Do you publish a frame for that object, or what do you publish exactly?
We publish a custom message,
Uh-huh.
but it's labeled with the frame.
Okay.
Has a
Okay.
standard header
Yeah.
with the frame.
Okay, yeah. So you indicate in that custom message, you indicate the frame from which you are providing the X, Y, and Z coordinates that you have detected.
Exactly.
Oh, okay. Okay. Okay, great. Then, so as you mentioned, you are getting the information, the recognition information from the Darknet ROS
Yes.
package. Can you tell us something more about this Darknet ROS? What is the relation with YOLO? What is YOLO?
YOLO, you only log once.
Okay.
It's YOLO, also called Darknet, is an open source neural network framework writing in C and CUDA. It implements a very efficient and reliable convolutional deep neural network.
Okay.
So it's independent from ROS, but you can use it like a library incorporated in your node, and that is what Darknet ROS did. They
Okay.
incorporated YOLO as a library, and it covered by a ROS interface,
Uh-huh.
and it is using that.
Okay, so yeah, so that's like providing this convolutional recognizer to ROS in its topics and services. I don't know which kind of. I never
Exactly.
use it. Yeah, never use it, but
It's very powerful. It's very reliable. You can train again with your own classes, and it's a C library, but it has a C++ header, and you can compile inside a node like a library, and it's very powerful. Yes.
And then you mentioned about the models that you can train. So if I have understood correctly, the YOLO system or the Darknet ROS already comes with pre-trained models.
Yes.
Yeah, and how does it work?
When you download Darknet, you have to download the weights of the network apart. But those weights are trained with the COCO dataset.
COCO dataset,
So,
okay.
Yes, the COCO dataset is a very big dataset with a lot of elements, classes, and you can use it. It perfectly out of the box detect people, detect caps, books,
Wow.
dogs, cars,
Wow.
almost anything.
Wow.
Yes.
Okay, but then, for example, I remember when we were working for the RoboCup. So I was participating at the RoboCup, and then at the RoboCup at home specifically, the one that you mentioned before. And then at that time, we had to recognize some specific objects, and provide a label. And for those situations, we have to train our system, and then we even built a platform where we are going putting the like a pizza, the pizza platform where you
Yes.
put the pizza and then you rotate, and then you put
Yes.
in front of the camera and take several pictures, and then you train. So can you do that with the Darknet ROS package?
Yes. Yes. Yes,
But-
you can do it. In the competition, you have to detect more classes that are present in COCO dataset. So you have to
okay.
retrain. In any case, you have to retrain. To retrain, you can use the method you want.
Okay.
The problem with the training is in a convolutional network is you have to manually label every image.
Exactly. Yeah.
If you use a system like you said with a rotational, you can take a lot of image where the object is in the same position in the image,
Yeah.
but the object changes. So maybe that is a system for avoiding to manually label all the images. But normally you have to take images of the object in all the position, and any person have to spend hours and hours in labeling that object where is in the image in order to create a data set, a labeled data set to train the neural network. Usually you do another things. You do data set augmentation with little variation of brightness and contrast and colors, in order to make the network reliable.
More robust.
Because you don't want that the network learns colors.
Yeah.
But shapes and all those kind of textures, those kind of things.
Yeah, it's like applying a little bit of domain randomization technique to you.
Yes.
Oh, okay. So then, sorry, but it was not clear to me then how are you going to do it at the competition? So if you have to do this specific, so recognize, let's say, this specific bottle, or this specific object. So how are you going to do it during the competition?
The objects in the competition are published.
Already?
So, yes, already.
Okay.
It's already published. So we are planning to bring the network trained from Spain. But in the case we have to retrain, we'll have to take all the images, and anyone has to label the images all the night and spend one day to retrain the network. Yeah.
Okay. Yes, the intern. Yeah, probably.
Yeah.
The intern will have to do that. Okay. And then this Darknet ROS, does it work with CPU, based on CPU, or also with GPU? You making use of the GPU?
You can use it with both, but the difference in the performance are very big.
Is it?
As you can imagine.
Yeah.
For example, we will use the NVIDIA Jetson TX2, and with that GPU we will work in frame rate, maybe 15 frames per second.
Wow.
If we will use the CPU, we will have one frame per second or less.
Wow. Okay. Yeah, 1 frame per second. Yeah, it's kind of like it's a little bit slow. Yes, you can see that is thinking. The robot is thinking. You can feel it.
Yes, actually, many people have the GPU, and when they run the first time the YOLO, they say this is very slow, and it's because they didn't activate the GPU compilation, or they don't have CUDA well installed, and they think they are compiling for CUDA and GPU, they are compiling for CPU. It's very clear.
The difference is very clear. So yeah, so if you can see that that is very slow, then if you feel that is very slow, then it's definitely you are not using the CUDA course.
Yes.
And then how do you execute that for the robot during the competition? So are you executing those packages inside the robot, so on the computer of a robot, or you have another specialized computer like the NVIDIA Jetson outside of the robot, and you communicate using Wi-Fi or something?
We are not going to use Wi-Fi for the recognition.
Well
you
done.
can put your laptop on top of the robot.
Okay.
So most of the computation will go in the laptop. And the detection will be in the Jetson, that is also connected by a cable to the robot. It's in the back of the robot.
Okay.
And we could use the robot, the computer inside the robot, but we are going to share the robot with other teams, and we don't want to do any interference with the other teams. So we will use the robot only like
for the topics,
yes.
for the accessing the topics, because it's the computer that is providing the topics and all that. Yeah.
Yes, accessing to the sensors, to the actuators, and nothing more.
Yeah. Okay. Makes sense. Okay. Yeah, because I remember in previous competitions of the RoboCup when those convolutional neural networks started to be successful and everybody was starting to use it, but the problem was that people required an expensive computer that was outside the robot, and it was actually outside the arena of the RoboCup, and then they have to communicate, but the only way was by using Wi-Fi, and that was not very reliable. Yes.
That happened to us in Canada when we participated in La RoboCup. the internet connection was not reliable,
Yeah.
and we had a Jetson in the table next to the arena, and we used that for recognition. But in this case, this time we will use the external computation only for dialogue, because we are using Dialogflow and we are using web services for the dialogue. But we have alternatives.
What do you mean by dialogue? Dialogue?
Dialogue is the Dialogflow to talk, to understand, to do natural language processing.
Okay. The dialogue between the robot and the person.
Yes.
Okay.
For the dialogue, we will use Dialogflow.
Okay.
And
what is this Dialogflow? I don't know what it is.
Dialogflow is a service that uses TensorFlow. That is another framework for deep convolutional network and everything.
The one from Google, yeah.
Yes, and they have a service, a web service called Dialogflow. You can configure it a conversation in an interface, and you can configure that. My student Jonathan Gines is in charge of that part, and he did a good work with that. But we need external computation for that.
Okay.
If the network is not reliable, we will use alternative methods like tactile screen or QR. QR marks.
QRs.
Yes.
Okay. Great. Then let me see another question here. So I have some questions about the point cloud, but you already have explained. Then, and also, about the performance, I wanted to ask you. So how is the performance in the recognition? I mean, so we know that those systems, when you apply into a data set, a database that is already being prepared, then the numbers are very good. But when you put it into the real situation, so for example, the challenge. So did you have the chance to test it and tell us if it is so good recognizing in real conditions?
Yes, it's good.
It's good.
It's good. You detect the person very well, and you detect the classes that are trying it. If you want another classes, you have to work a lot in order to make it work, because you have to give to the network in the train enough information. The network has to be well trained, and you have to do a lot of things. But out of the box, Darknet ROS works very well.
Okay, and the light conditions and so on. So
no problem with that.
Strong with that. Okay,
it's reliable. Yeah.
Okay, that's amazing. So,
but you have to solve another things.
Which one?
For example, in the RoboCup, you don't have only to detect a person. You have to differentiate one person from another.
Yes,
and that is your work.
Oh, okay. Okay. Yeah, but that's. Okay, that for that I am okay, but the problem that we had at the RoboCup was to actually identify the objects. No, identifying the object was already a pain, and then with this system, it looks like it's like a solved problem. It's like a solved problem. So
yeah,
amazing. And then, so how do you plan to use your package Darknet ROS 3D for the competition? In which part of the structure of your architecture are you putting this for maybe for identifying where there is a person and then approaching that person, or maybe to identify where are the objects in order to grasp?
In the competition, we participate in the deliver coffee shop orders and take the elevator. The first one, you have to detect if when the robot is in front of a table, it has to detect if there is something in the table and how many people are sitting the table. When you go to the barman with the order, you have to detect if the order is correct. If you ask for 2 beers and 1 Coke, he could give you 3 beers, and you have to say, no, it's it's wrong. And in the elevator, you have to detect all the people in the scene in order to do a correct social navigation, to respect the prosemic of the people and those kind of things. And in our architecture, we have a software architecture it's a classical 3-level software architecture. We have a planner. We use ROS plan, for example, to planify. And we have developed a knowledge graph. It's like a graph with nodes and arcs that connects concepts. And when anything is detected, in that graph, we insert the element like a node. And we insert not only an arc that say that you see a thing, that the transform from any frame to the new detected element.
Object, yeah. Okay.
Yes, it's a very advanced research, and we will publish next, maybe in September, October. We are planning to publish that for ICRA, maybe.
Oh, okay. And what about the code? So you are talking about the paper, publishing the paper. Yeah.
Yes.
And what about the code? Are you going to release that code, or is already there?
It's everything available in our GitHub, so anyone can use whatever they want. Actually, we have a toolbox for developing intelligent behavior called Vika. And anyone could use Vika for this. It includes some substitution architecture, some reactive behaviors, planning, and this graph of knowledge. Anyone could use for the purpose they want.
Oh, great, amazing! So I'm eager to have a look at that framework. I didn't know about the Vika thing, and it is published in your GitHub of what of the Robotics Lab or your personal one.
No, we are the Robotics Lab in the university is split in several groups. Mm-hmm. I'm the leader of Intelligent Robotics Lab, and we have a GitHub, the Intelligent Robotics Lab. I can give you the URL for displaying here. Okay. And in that repository are all the software we are developing for the competition. Everything is open, as is available to anyone. Contribution are welcome, anything. Great.
So please, ROS developers that are listening there, please have a look at this amazing software package, and please contribute and provide the insights, errors, corrections, especially, and whatever to these guys, to the guys of the Intelligent Robotics Lab. Great. So I will put a link beneath the notes of the program where people can access that Vika package. Okay. And so a couple of questions more about your package, the Darknet ROS 3D. Which requirements in terms of versions of ROS? So does it work for which ROS version?
All the software we are developing are officially developed for Kinetic.
Okay.
Everyone has Kinetic, and this is a strong rule for when you participating in a competition. Everyone has to have the same version of ROS, but I am the only one that use Melodic.
Okay.
So it's compatible with Melodic. That is because I do contribution for ROS2, for example, and we need to have the Melodic in order to have that in the IDEMA distribution. And that's the reason why I use Melodic, but everything is compatible with Melodic.
Okay, I didn't understand that about the Dashing Diadema. Just for the ROS developers that are listening, Dashing Diadema is the latest ROS2 version that has been published. So what is the relation? Sorry, I didn't understand what is the relation between ROS2 that you mentioned and the reason that you have to use ROS Melodic.
Because if you want the latest version of ROS2, you need Ubuntu 18.04, and you can't install Kinetic with that version of Ubuntu.
Okay, because the official one is Melodic for Ubuntu 18. And then, if I understand, then you have both distributions, ROS2 dashing and ROS 1 melodic, and then you play and then you do your experiments or whatever.
Yes, actually, in all the software, there is only one package that requires to have a branch melodic. The other, you can use the master branch of all repositories with both melodic and kinetic.
Okay, great to know. Then finally, final question is about any other. So we have been talking about the Darknet package and the YOLO detector or object recognizer. Then any other object detector, object recognizer that your competitors may be using and that you would like to recommend to the ROS developers?
For deep learning alternative, you have TensorFlow and Keras or Coffee to detect objects. As an alternative to deep learning, you have Object Recognition Kitchen. It's a software that is used by many people of RoboCab. It's a software you can train objects and it has a detection method. You can also use Object Recognition 2D, Object Detection 2D. It's a package, it's an official package in ROS, but the object has to be planar and it detects biomography. It's actually, if you use a 3D camera, you can have the position of the camera with respect to the object you are detecting. So it's very useful for 3D detection. For detecting people, you can use OpenPose. OpenPose is a good election. You have a good GPU because it's very heavy. And you can also use libraries of Python or many function OpenCV for detecting faces and recognizing faces.
Okay, yeah, but that will require a lot of work, isn't it? For make it work in a proper. I mean, using the OpenCV libraries and I know that they can recognize the faces, but it requires a lot of work to build on top.
Yes, actually, for objects you can also use point cloud library, PCL, but that is very heavy and the results have not been as good as we would like to in the past.
Okay, so I'm writing down all those options that you provided, and I will include a link on the notes of the program. And okay, so that is all from my side. Thank you very much, Francisco, for being here a second time. It's always a pleasure to chat with you and discuss about new things about ROS. Thank you.
It's a pleasure to have with all the ROS developers here contributing to the knowledge of the community.
Okay.
Thank you.
Actually, I will put an image that you sent me some months ago about your Pepper robot that was on the touch screen and you have the logo of the ROS Developers Podcast that you sent me from your lab that you were listening to the tune of the ROS Developers Podcast.
Yes.
So thank you very much for that. Thank you.
Thank you.
Okay, and for all the listeners, let me remind you that if you want to learn to program robots with ROS, then you should have a look at the Robot Ignite Academy. We have created the 30-70 teaching method, which is based on a 30% learning theory and 70% of the time practicing with simulated robots. We provide a complete path for beginners, starting by teaching you about Linux for robotics and Python for robotics. Then we continue with the basics of ROS. And then at the end, you will build your own ROS robot step by step. Have a look at the www.robotignite.academy. I will put a link beneath the notes of the program. And that is all for today. Thank you very much, ROS developers there. See you next week with a new lesson from the experts. And until then, keep pushing your ROS learning.